And here we have one more problem related to the same ideas somehow. It's related to everything we have studied or we are solving. So you can see that this problem says a plate, sorry, in form of an equilateral triangle. Yeah, there is a plate and it's equilateral with a side L up L root 2. Yeah, root 2 is the side length. Is uniformly charged with a surface density sigma. Yeah. Find the electric field E at a point O located at the same distance L from each of the vertex. Oh, we need to find the electric field. So you can see this picture. But before seeing all those things, we will derive a useful general formula. Yeah, we do it sometimes. And this formula will be something like F perpendicular equals sigma phi. And what is it? Phi is the surface charge density of a uniformly charged plate, and pi is the flux of external electric field. And it need not be homogeneous. It may be uniform or non-uniform electric field. It doesn't matter. Through the plate. That means we got a plate of surface charge density sigma and flux of some external electric field as phi. And in that case, it feels a force normal to the plate, and this force we are going to call it F perpendicular. So F perpendicular is basically the normal component of the force on the plate from the external electric field. And to do so, we are going to have a small piece of plate having an area ds and a charge dq, so that we can write here sigma is definitely equal to dq upon ds, and we can write dq equals sigma ds. Well, this is all right. And the force, normal component of the force due to an external electric field on it, on this point charge dq, will be simply df perpendicular, and we can write it the perpendicular component of electric field there multiplied by charge dq. These are all basic electrostatics. So, and now I'm going to find out the net force acting on the plate, the normal component of the net force acting on the plate. An integration can do this. So we can integrate df perpendicular simply to find out the f perpendicular, and that will be simply like I would like to write e perpendicular. In place of dq, I would like to write sigma ds, and you can take the sigma out and rest of the thing inside the integration, and it will become e perpendicular ds, and normal component of electric field multiplied by the area element ds. And you know, this is nothing but the flux. This thing is flux passing through the surface. So I think we have calculated this result and this theorem. And now my plan is something else. I'm going to look at this picture, and you can see here we have an equilateral triangular plate. If you can't see, you can focus your eyes here and you will see it. This is the triangular plate with side length L root 2, and there is a point O that is located at the same distance L from each vertex of the plate. And so, how did I take this equilateral plate? You can say I drawn a cube here and cube of side length L. You can see here, so that their diagonals will become of length L root 2, and I have taken three faces of the cube. One, the face that is facing upward, this is the side face, and this is the front face. And I just composed my equilateral triangle plate joining these vertices, and I got it. This is drawing, nothing else. And what next? I got then in this case you will see that this corner O is definitely the equidistant point from all three corners. This, and this. The distance is L. Yeah. So this is a bit of drawing. And now I'm going to place a test charge Q at point 2. Yeah. And I'm going to find the electric field at this point. And since here is a point, here is a test charge Q, so force F acting on this test charge due to the plate, we need to find out. And according to Newton's third law, the same is magnitude of the force F on the plate as well. If plate exerts a force on point O, on a test charge placed at point O, the point O in return will exert the same force on this triangular plate. So we have symmetry, and we have many things else. So I can also see that by virtue of system symmetry of rotation by an angle 2 pi by 3 about an axis passing through the point 2 and the center of the plate, the force F is directed along this axis. That means what I'm trying to tell you, that I have a triangular plate here like this, and there is a point charge Q somewhere up. I can't show you in this diagram, but you have to imagine. And this is a kind of I guess tetrahedron like picture, and you will assume that the force at this point, charge Q, is along the normal or along the perpendicular drawn from point O to the surface of this triangular plate, and the force will be in the same direction. Well, normal to the plate, triangular plate, and so you can see here that F is basically the F perpendicular we are looking for, and electric field will be force per unit charge, per unit test charge, and that will be sigma pi upon q, where pi is the flux of the electric field of the test charge through the plate. And you can note that the plate and the test charge can be placed inside and on the surface of the cube that is already shown in this figure. Yeah, this test charge q is placed inside and on the surface of the cube. Yeah, and now you can think bigger. Eight touching cubes will common vertex O completely surrounds the charge cube. What I told you that you need to think that there are eight cubes like this. Yeah, they will have a common vertex O and they can completely surround the charge cube. You will be needing 7 more like this, altogether 8. And O will be the center of this 8 touching cubes. Yeah, and so the flux through the 8 cube system will be simply a small q by epsilon naught due to discharge q, and only 1 by 8 of the total flux from the charge q is the flux passing through this rectangular from this triangular plate. Yeah, there are 8 triangular plates like this in this 8 touching cube, and so this is 1 by 8 of the total flux q by epsilon naught, and you are going to get the electric field, and that is sigma flux is q by 8 epsilon naught divided by q, and the result is nothing but sigma by 8 epsilon naught, and that's your answer. You watch it again and again and you will know what I'm trying to say. Thank you very much for watching.